What's up, guys? Welcome to my channel. As you may know, I've been doing this physics crash course series, and in the last video I started off just by introducing vector and scalar quantities, but now we're going to talk about units, because units are going to be super important in physics. Don't forget, follow me on Instagram. My Instagram handle, or username, sorry, is Marty Nicola with 2 A's. And yeah, man, like, follow me, and I'm usually open to getting some questions through Instagram, and then I'll typically post a video about it on YouTube and answer those specific questions that you might have. That's how I work, or how I run. Anyway, but yeah, so welcome to physics, class 2. So this class is on, or this lesson is on SI units. Now, units, there are standard units of measurement for things like, let's say, mass, or velocity, or distance. There are units that aren't as widely used as other units. The metric units are the ones that we're going to really focus on here. So we got, what do we got? So let's do this in blue. Ooh, no, red. Okay, so mass. Let's do mass. Okay, mass's units are in kilograms typically. Okay, so you might see a question, and the first thing you have to do is make sure the units for mass are in kilograms. Okay, what about distance, or displacement, or position? Distance or displacement. What are the units for that? Well, these are in either units of, well, let's say units of meters. Okay, so meters, that's the units for distance or displacement. Let's say, what else are we going to get? We're going to get velocity in this course. Obviously, velocity or speed. Velocity or speed. What are the units for velocity or speed? That's going to be meters per, whoops, that M looks nasty, meters per second. Okay, so this means you go a certain amount length, or meters, distance, in a certain amount of time. Okay, so we're going to see an equation in a later lesson that has to do with calculating speed or velocity, and it has to do with either distance or displacement over time. So we're going to see that cool equation. All right. What else? Force. Force. We're going to see force in unit 2 in this course. Force has units of newtons. We talked about this in the last video. So this is newtons. That measures the strength of a push or a pull. So yeah, those are the units that we're really going to be focusing on in this course. So as I mentioned, we'll have to calculate velocity or speed. This equation that we're going to see later on is going to be v equals d over t. This guy is going to be in unit 2, and that's where we're going to introduce Newton's laws. Okay, Newton's laws, and free body diagrams as well, and things like that. Yeah. Distance or displacement. So yeah, so that's basically an intro to units that are really going to matter in this course. I'm going to be posting some videos about specific questions that deal with units and how to convert between units. Actually, I might as well talk about that now. That might be useful. So let's say, new page after. So let's say I've got 10 grams. Okay, so mass is 10 grams, and I want to convert this to kilograms. Here's how I would do it. 10 grams, okay. If I want to convert that to kilograms, I have to multiply by a conversion factor. Okay, so here's what I would do. I would determine how many grams are in 1 kilogram. I already know the answer to that. So 1 kilogram equals to 1,000 grams. So here's how I'd multiply the ratio. I have a G over here, so I'd leave the G on the bottom and I'd go 1,000 grams, and then on top I would put the kilogram. Now what this serves to do is it cancels the G's and it leaves me with kg, the kilogram unit. Okay, that's how it convert. So basically this would turn into 0.010 kilograms. So to convert between the two, I basically just divided, so this is just dividing by 1,000. Okay, but this is how you would do it formally. Okay, so you would do it formally by doing this conversion. So this is a conversion factor. Conversion factor. Okay, so let's try converting, let's say we've got 10 kilometers. Okay, 10 kilometers equals 10 kilometers, and the conversion factor will be 1,000 meters per 1 kilometer. Okay, so now if I want to convert back to meters, which is the SI unit, I would have kilometers on top and on the bottom, because then they would cancel each other. And basically what I'm doing here is I'm multiplying 10 by 1,000. Okay, so that's the operation that I'm applying here. 10 multiplied by 1,000, and I end up getting 10,000 meters. There you go. So that's how to convert kilometers to meters. Now, how would I convert meters per second, or let's say kilometers per hour, to meters per second? So 40 kilometers per hour. Okay, and I want to convert it to meters per second. So I do the same process. I make sure that there are units on top and on the bottom in my conversion factor. So I go 40 kilometers per hour. Okay, now here kilometers is on the top, so I'm going to have to create a conversion factor that is kilometers on the bottom. So 1 kilometer, and then this is going to be 1,000 meters. That's equivalent. And then in blue, I'm going to do the same thing, but now I need an hour on the top, because that has an hour on the bottom. An hour on the top over the corresponding number of seconds in an hour, which is 3,600 seconds. Okay, and there you go. So now I can cancel kilometers, cancel hours, and basically what I'm doing is I'm going 40 times 1,000 divided by 3,600. So 40 times 1,000, divided by 3,600, and that'll lead me to meters per second. Meters per second. Okay, and there you go. So what's 40 times 1,000? Okay, so that's 40,000 divided by 3,600. What do you get? So 40,000 divided by 3,600, you get about 11.1 meters per second. Okay, so that is the unit. Sorry, these are equivalent speeds in different units. So kilometers per hour is approximately 11.1 meters per second. So there's a shortcut when you want to convert speed, by the way. So the shortcut is basically kilometers per hour to meters per second, you divide by 3.6, and you will get meters per second. Okay, so that's a shortcut that we might want to use later on in a future video. You just take 40 divided by 3.6, you get 11.1, and that's it. Basically, that's the SI units and converting across different units. So you'll be provided with problems where you have to convert, 10 grams to kilograms, and you might need this conversion factor. Okay, so it's a conversion factor isn't really the most preferred method, but I feel like it's easier to make sure that you don't make a mistake by applying the conversion factor. So it's something to consider. Anyways, this is great, and I'll see you in the next lesson. Don't forget to subscribe, like if you enjoyed the video, and I guess I'll see you in the next one. And yeah, this is fun. All right, peace out, guys. Love you. Bye.